There is a place in the universe where gravity is so powerful that nothing can escape it. Not light, not matter, not even time, at least not in the way we normally experience it. And if you got too close, you wouldn't simply be crushed. You would be stretched apart, atom by atom, until you became a stream of matter falling into darkness. This place isn't on some distant planet. It's a black hole. And somewhere in the universe, there are black holes so enormous that our entire solar system could disappear inside them. But the strangest part is what happens before you ever reach the point of no return. Imagine approaching one. From far away, it looks almost like nothing. A black circle surrounded by distorted light. But as you get closer, something bizarre happens. The universe around you begins to bend. Black holes don't just pull objects toward them. Their gravity warps space itself. Light from stars behind the black hole can be bent around it, creating strange arcs and rings in the sky. You could actually look in one direction and see light that came from behind you. The closer you get, the more extreme this becomes. And eventually you reach something called the event horizon. It isn't a solid surface. You wouldn't crash into it. There isn't a wall. It's simply the boundary beyond which escape becomes impossible. Once you cross it, there is no turning around. Not because your engines aren't powerful enough, not because you aren't moving fast enough, because every possible path through space-time leads deeper inside. Even a beam of light fired directly away from the black hole cannot escape. And this creates one of the strangest effects in the universe. To someone watching you from far away, it would appear as though you slow down as you approach the event horizon. Your movements become slower. Your light becomes increasingly red and faint. Eventually, you seem to freeze near the edge and disappear. But from your own perspective, you cross it. And you might not notice anything unusual at that exact moment. That's because the event horizon isn't where the real nightmare begins. The real nightmare depends on what kind of black hole you're falling into. A small black hole would be incredibly violent. Its gravity changes dramatically over very short distances. Your feet could be pulled much harder than your head. The difference would stretch your body vertically while squeezing you from the sides. Scientists call this process spaghettification. And the name is almost too gentle for what it means. You would be pulled into a long, thin stream of matter. Atoms would separate. Molecules would be torn apart. Eventually, even the structure of your body would cease to exist. But here's where black holes become even stranger. If the black hole were enormous, you could cross the event horizon without being immediately torn apart. That's because the larger the black hole, the weaker the difference in gravity between your head and your feet at the horizon. So you could pass the point of no return, still completely intact. And that's when you would discover something terrifying. There's no escape route. You could fire your engines, you could turn your spacecraft around, and you could accelerate directly away. It wouldn't matter. The event horizon isn't a place where gravity suddenly becomes infinite. It's a place where the geometry of space-time gives you no path back out. The deeper you fall, the stranger the universe becomes. Light bends more severely. Distances become distorted. And eventually, according to Einstein's theory of general relativity, everything you've brought with you is heading toward a region called the singularity. This is where our understanding of physics breaks down. The equations predict matter being compressed into an incredibly small region with extreme curvature of space-time. But scientists don't actually know what exists there. And that's important. The singularity may not represent a literal point of infinite density. It may be telling us that general relativity is incomplete, We need a theory of quantum gravity to understand what really happens at the center of a black hole. So the most dangerous place in the universe is also one of the places where our understanding of the universe itself reaches its limit. But black holes have another trick. They can destroy entire stars. We know this because astronomers have actually watched it happen. Sometimes a star passes too close to a black hole. The black hole's gravity grabs one side of the star more strongly than the other. The star stretches. Then it tears apart. Its material spirals around the black hole, forming an enormous disk of superheated gas. For a short time, this destruction can produce an incredible burst of radiation. The event is called a tidal disruption event. And from billions of light years away, telescopes can see the aftermath. But some black holes are far more terrifying than the ones destroying individual stars. At the centers of many galaxies are supermassive black holes. Our own galaxy has one. It's called Sagittarius A star. It contains roughly 4 million times the mass of our sun. And yet from Earth, it doesn't look like some giant cosmic vacuum cleaner. That's because black holes don't automatically suck everything toward them. If the sun were somehow replaced by a black hole with exactly the same mass, Earth would continue orbiting almost exactly as it does now. We wouldn't be sucked in. We would simply lose the sun's light and heat. The danger comes from getting too close. And there are black holes so massive that their event horizons would stretch across distances larger than the orbits of planets. The largest known supermassive black holes contain tens of billions of suns. Imagine replacing our solar system's center with one of those. The black hole would be so enormous that planets could orbit within its gravitational domain while still remaining outside the event horizon. And yet, despite everything we've learned, black holes remain strangely invisible. We cannot see the black hole itself. We see what it does, stars orbiting something we cannot see. Gas heated to millions of degrees, light bending around an empty-looking region of space. And in 2019, humanity finally captured something extraordinary. The first image of a black hole's shadow. It wasn't a photograph of the black hole itself. It was the glowing material surrounding it, with the black silhouette created by light disappearing into the event horizon. For the first time, something that had existed only in equations for decades became visible. And perhaps that's what makes black holes so terrifying. Not that they are monsters wandering through space looking for planets to devour. They don't need to hunt anything. They simply sit there, quietly bending the universe around them. A star can shine for billions of years. A planet can survive for billions more. But cross the wrong boundary around a black hole, and the universe stops offering you a way back. Because somewhere beyond that darkness is a place where our equations stop making sense. Light cannot escape, and everything that enters is carried toward a destination we still don't fully understand. The most dangerous place in the universe isn't dangerous because of what we know is inside it. It's dangerous because beyond that final boundary, we still don't know what the universe is hiding. Until next time, stay curious.